All right, everybody. This is my house and my turtles. That guy looking at you is the one that you guys know. That is Squirt. The little guy is nameless yet, but here's Melman. He's taking a nap. I'm going to show you now how to draw a schematic drawing for problem number 28. It is on page 295 of your textbook and the solutions manual that you can find on the assignments page. Thanks to Wiley, the publishing company. They've made that available for you guys free. And it has the solutions not only to the odds, but to the evens as well. All right, here we go. So the first thing is we need to find the velocity. We need to find where this particle is stopped. We need to find the acceleration and determine where it's speeding up, where it's slowing down, and then graphically interpret it with a schematic drawing. Okay, so one derivative away from the position function, or ds dt, is what the velocity is. In the next chapter, we're going to go the opposite direction and take the antiderivative of the acceleration, the antiderivative, to get to the position function. But in this chapter, we're taking the derivatives to go from position all the way down to acceleration. So the first derivative is, I hope I don't make mistakes here, it's factorable. We can pull a 3 out. We're setting it equal to 0 to find out where this sucker is stopped. If we're ever doing a video and you can't see or you can't read it, make sure you shoot me an email, because I'll try to do a little bit better job the next time. What times what's 3 added together is -4. Setting that equal to 0, you get t equals 3 and t equals 1. So on a slope of the tangent line testing number line, that's what we used to call them. Now we're going to call them the velocity number line. We're going to put those two critical values there, 1 and 3. We're going to determine the nature of the velocity. You remember, if it's negative, it's going left. If it's positive, it's going right, or down and up, depending on what kind of particle it is. So test a point like 0. It's not critical. You throw a 0 in there, and it's +9. So at t equals 0, it's positive. It'll alternate on signs, alternating sign changing trick on roots of odd multiplicity. We know we're going to put the acceleration right beneath it. So I riddle this area with positives, negatives, and positives. It's easier for me to see where it's speeding up and slowing down if I do that. Okay, the next thing we have to do is take the second derivative, or it's the first derivative of the velocity, which is dv dt, s double prime, or the derivative of s with respect to time twice. And here we go. I always use that polynomial from up above. You could use the factored part of the polynomial too, but just to make sure, I like to use the regular one. It will factor just the same. Pull out a 6. And we get t equals 2. So t equals 2 is another critical value, but this time based on the second derivative or the acceleration test. We put that 2, we would have put it right between the 1 and the 3. Vitally important, you got to be able to put it right between the 1 and the 3 here. So when we test the nature of the acceleration by putting in a 0, it's negative. And if we put in a number bigger than 2, it would be positive. All physicists know that our experiments start at 0, so we put that t equals 0 and we ignore everything up front. These are our critical values that we're going to need to know their position at those spots. We need to know the position at 0, 1, 2, and 3. And so I already plotted it in my calculator and put it in and gathered these data values from the table to speed up this process. Here comes the position one-dimensional number line. On this position one-dimensional number line, we have 1, 1 unit to the right of the origin, 5, 3, and 1 again. At t equals 0, we start at 1, and we travel to the right. So we would travel all the way to 5. We would slow down, hit 5, and turn around and travel all the way back to 1. We would hit 1 and turn around and go all the way back to a positive infinity. We would stay on that horizontal continuum, and you wouldn't be able to see those motions. It would go from here to here to here. So what we do is we hover up above that s-axis and start with t equals 0. We travel all the way until t equals 1, and at t equals 1, we wind up at 5. And we're ready to turn directions. So at this spot, where the position is 5, that's time value of 1. Notice at 1, we turn the corner, we go back, or we stop in our tracks like you're doing a suicide in basketball practice. You stop in your tracks, and now you're heading the other direction. And you head the other direction until t equals 3. At t equals 3, the position is 1. So you'll stop at 1, stop in your tracks. If you don't touch the line, your coach will make the entire team do it again. And there we go. I put the directional barbs on at this time. You know, technically, there's you only have to put 1. I'm requiring that you put 1 additional 1. And so I know we're going this way, that way, and this way. There's some textbooks that just absolutely riddle these schematic drawings with those directional barbs. Okay, now we need the legend of where it's slowing down and speeding up. I'm going to use railroad tracks for slowing down. This particle is slowing down. Oops, erase my 1. Put vertical lines through all your critical values. It's slowing down when they have opposite signs. So, from 0 to 1. Stopped. We stop in our tracks, and we go the other direction. I'm speeding up from 1 to t equals 2. Well, that's the value that I haven't plotted yet. I haven't plotted where t equals 2. In fact, I forgot to label one of my time values. Can you see it? Which one I forgot to label? Right there, t equals 3. We're back at position number 1. So we're speeding up, speeding up, speeding up until we get to t equals 2. At t equals 2, the position is 3. That's this guy right here. So when t equals 2, there's the position at s, or x, equals 3. We speed up until that point, and then we throttle it down because eventually we're going to have to put on the brakes, stop, and go the other direction. So from t equals 2 to t equals 3, from t equals 2 to t equals 3, negative velocity, positive acceleration. When they have the opposite signs, it's slowing down. Stop. And pick up speed and go the other direction. Guys, I hope this was helpful to you. That's how you draw a schematic drawing. And say one more goodbye to the old turtles. We'll talk to you tomorrow. Have a great night. Stay healthy.